Hello and welcome to our virtual lunch and learn today. We'll be talking about STOBER integrated gearbox servo motors. My name is Rachel Green and I'm the digital communication specialist here at McNaughton-McKay Electric Company. Presenting for us today will be Dave Graff, business development manager at STOBER, and he's joined by John Davis, president of Paul Davis Automation and STOBER sales engineer for Ohio. Ready to answer your questions out in the comment section today as well is Randy Mueller, McNaughton-McKay systems engineer out of our Toledo, Ohio location. Feel free to enter your questions in the comment section as we go along, and we'll have a Q&A portion at the end for Dave and John to answer those in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual lunch and learns on the YouTube channel under the virtual lunch and learn playlist. And we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual lunch and learn today, STOBER integrated gearbox servo motors. Let us know where you're joining us from. Our specialist, Randy Mueller, is available to chat with you in the comment section, and Dave and John, our presenters, will be available to answer your questions during the Q&A segment at the end of the presentation. If you'd like to reach out to us afterward, or if you have further questions, you can send us an email at macandmaclive@mc-mc.com. Just be sure to let us know the session that you attended, and we'll have that email address on the screen at the end for you as well. All right, looks like we have a few attendees here with us now, so let's go ahead and get started. John, I'll pass it over to you.
Thank you, Rachel. I appreciate it, and thank you for everybody who's joined and who will watch later on the recording. I'll just make a quick introduction for myself, and then this is the Dave Graff Show, so I'll hand it over to him. So, as Rachel introduced, John Davis, president of Paul Davis Automation. We're a manufacturer's representative firm based here in Ohio, and we handle Ohio, Kentucky, and Western PA. And our product lines are motion control oriented product lines. So we have a basket of technologies, all for high tech, high speed, high precision motion control applications, with a specific focus on supporting our Rockwell partners. So we work with McNaughton-McKay and other Rockwell distributors throughout our region. So all that said, Randy Mueller had reached out to me and asked if we had any new and exciting technology to update our McNaughton-McKay customers with. And I said, absolutely, yes, we do. The STOBER gear motors, it's a servo gear motor. That's a very unique technology from STOBER, made here in the United States in Kentucky. And since Dave Graff is the motor expert, I will hand off the presentation to him. And again, thank you everybody for your time. I really appreciate it. Thank you.
John, I appreciate it. Thank you, Rachel. To all those joining us, appreciate your time today. I want to talk to you about what STOBER can do to shift that technology curve on your machine. We want to make your machine perform better and help you improve the function of the machine. We're going to look at the STOBER gearboxes and the STOBER integrated gear motors. We call them synchronous geared servo motors, and some of the other ancillary tools that go with that, including rack and pinion and dynamic brakes that we're working with Rockwell. And we're just going to talk about integrating that real quickly into your Kinetics 5500 and 5700 systems. We'll pretty much ignore the 6500. It's the same as the 5700, but a lot of you aren't using it anymore. So who is STOBER? STOBER was founded in Pforzheim, Germany back in the 30s. They were making machines to repair engines. They started out making some gearing in that for motorcycles, and we're an international organization. We have offices in 11 countries. We are the largest subsidiary of the parent company here in the United States. We have about 160 employees in Maysville, Kentucky. So where is Maysville, Kentucky? Maysville, Kentucky is about an hour east of Cincinnati on the Ohio River. It's a small farming community here, a small town community that has a very reliable workforce, and we're one of the main employers in that area. So we retain our people well, and we've got a long heritage there. We just celebrated our 30th year in Maysville. So the STOBER Rockwell relationship goes back quite a few years. Started out as one strictly with our gearboxes, and now has evolved into one with our integrated synchronous geared motors, as well as the addition of some safety brakes in that now as well. So we're what Rockwell lists as a bronze technology partner, which is simply the level of integration into their systems. So We help because we have millions of choices, and that may sound overwhelming, and that's why we're willing to help, but that allows us to solve your application differently than our competitors. So we change that, we do the paradigm shift in the design to give you a better choice, give you a better performance. So when we started looking at this modular line of gearboxes we offer, everything from helical bevel, inline, offset, to planetary, to combined units, all this combined together gives us a huge amount of choices in solving your application. And that's what we're going to talk about, is how we take these choices and then combine them with our integrated motors as well to even offer some additional benefits. So we just recently came out with our third generation of planetary gearboxes, and it's a gearbox. Yep, that's for sure. But there's some things here that give us an edge to help your machine get better. We're seeing substantial increases in torsional stiffness. Again, more compact design, and you'll see this compact theme run throughout this presentation when we're talking about integrated motors or even our own gearboxes. Everything we do is we try to make it very compact. So in doing this, now we're able to take higher input speeds and stuff, which again allow you to pick a larger motor, different ratio. Maybe the motor becomes smaller, so you're using less current, and it starts to magnify downward in the machine design. And we're able to get more torque out of these because we've widened these gears. We've got a much larger shoulder area there, and we're treating these gears with different types of technologies, and even a nitride on our housing, which reduces backlash in some of the units. And we're seeing upwards of 50 and 60% torque increases in gearbox sizes, which allows you now to pick maybe a smaller gearbox than you were picking with our competitors or something. So again, more compact, hopefully a better running machine. We've got new shaft seal options that are offering multiple lips, grease-filled lips that last longer, increase that shaft seal. Again, high temperature resistance to give you more ability to get around the stuff that kills machines. One of the more unique things to Stober is that in a planetary gearbox, we have bearing options as well. We can change the output bearing in our gearbox without changing the size of the gearbox, and now we have standard ball bearings or double row contact or cylindrical bearings. Again, based on the application, if you're putting a belt on there and going to tighten it so you can play Deliverance on a banjo, we got a bearing that'll allow that gearbox to last. Again, in the same package. We haven't made it any bigger. We just substitute the bearing. And again, we're offering more bearings in our flange style gearboxes. We're seeing shaft load capacities, radial loads up 39, 40% more, again, in the same package. So now that's enough of the new product. Here's where we shift the technology. Here's where we make it more customizable to your machine. We sell a ton of planetary gearboxes, just like our competitors. Inline planetary, right angle planetary, flanged planetaries. But what we do even better than a lot of people is offer you a solution of helical bevel units. Now this doesn't sound, it sounds sort of like almost old technology, if you would, but it's not. First of all, we're much quieter with a helical bevel unit, which is really nice in some applications. We can get higher input speeds in these and more output torque. The unique thing here is we have all these configurations of shafts and that mounting. You'll start to see that. But beyond that, when you buy a planetary unit and you go above a certain ratio, you go from a single stage to a double stage to a triple stage. Well, each stage increases your cost, each stage increases your length, and lowers your performance as you increase the number of stages in terms of backlash and wind up and all that. So we take a helical bevel unit and we can give you the exact same physical package with a 6-to-1 or a 56-to-1 or a 70-to-1. And we haven't changed the price. So now we offer this much greater range in gearboxes without physically altering the outside of the box. And we'll find in some of these cases, these really tuck in nice on the machine so we can get the machine better for the floor of the plant and fit in spots where you can't get. So when we look at them, we start to see this flexibility. We see housing styles with foot mountings. Well, if you ever want to do a planetary with a foot mount, you got to build a 90-degree bracket. We just say these feet, bolt on, you're done. Tab toll, square flange, round flanges, hollow shafts, solid shafts, wobble-free bushings, all these infinite choices on these helical bevel units. We can even do torque arm mount with servo. And I want to emphasize that we ship these out of Maysville all the time if you order it properly with 5 arc minutes of backlash. So this is not a unit that performs less than your Planetary. This is on par with good Planetary units. And it's a ratio that stays constant throughout the gearbox. So we don't have to worry about that changing over time. You start at 5, you're at 5 when you're done, 15 years from now. So got to get that going the right way. Here's one of these paradigms we're talking about. This is what we call our F box. And this box offers some unique abilities in physical mounting. You all have to do takeoffs of belts and conveyors or something that you're indexing. And a typical way to do that is to take a belt to a pulley, and then you stick that pulley to a gearbox, and then you put your servo motor on there. Well, that's all good and said, but if I now take this unit here, I can slide the shaft of that output right onto this unit. And guess what? I now have a mounting surface for my integrated gear motor, or if we must, a Rockwell motor in there. So here in doing this, I've taken away that belt and pulley. I've taken away that extra gearbox. I've put it all in this box, and I have a nice surface that doesn't need you to go out to the shop and have a guy build a bracket to go around it. And then it has to go from welding to sandblasting to paint. And then you have to come back and have somebody mount a tab on the machine. We're all secure here. We are oil filled, lube for life. We can do 6-to-1. We can do 276-to-1, all in this package here. So now we get this very tight on the shaft. We eliminate these components. And guess what? You spent less than you did on all those components. Very nice integrated unit, ready to go. When we look at this, we look at these gear motors, we see this adaptability, and we'll talk more about all of these, and this compactness. We're not going to find anything out there that's any more compact. We see a package unit, and we also gain some dynamics in having it all in one. And another big advantage, if you run your gearboxes close to the line, is that they do run cooler, and that is, heat kills the gearbox, so this means we can increase life. So these are applications where you would normally use a gearbox and a motor. We can use this. I will tell you, it may not be for every application, but in many cases, we have a better solution with an integrated gear motor. We eliminate the input. And by doing that, I bring this motor in tighter to the gearbox. I get rid of that bearing, I get rid of that coupling, I get rid of that frictional seal, that drag, and again, make the unit better performing, and much tighter fit in a machine. So space is an issue. This is where we would look at one of these. A packaged unit where it's already all one piece would be beneficial. You don't have to run out and find the gearbox on one shelf and the motor on another, and then go to another one and find the screws. And, so when there's heat in the application, we run cooler. We're going to show this a little bit later. When there's inertia is a problem, again, we're more dynamic. I just got rid of a large amount of inertia, and I'll show you those parts in a minute. If we're having issues with water egress, again, I'm tighter. I got a good seal there. We're much better to integrate into our system. So these motors are enabled motor products, if you would. They work our standard easy gear motors and an EZS work on DSL. We're on the Kinetics 5500 platform with Stegman DSL. We're on the 5700 platform with DSL. We can also do them in NDAT 2.2, which will still work with the Kinetics 5700 and the 6500. We'll have a whole line of hollow bore motors we're going to show a little bit later. Those are NDAT only. Stegman does not make an encoder that will work in that motor. So those have to be used with 5700 and 6500. And here's the beauty. We're using Rockwell cables. We're using the same cables you've got on the machine already. So you're not looking for new cables and you're not worrying about stocking an additional part. So what happens in Maysville is when we get an order for a Rockwell motor, we program it, we program the encoder already so that it has the files, the blob files are in it. And when you go and pull that in, I'll show this a little bit later, it's just like selecting a Rockwell motor. So we have these for 5500, 5700, and we just change the codes, which just tells us which wiring and which encoder we're using. But it is stuff that's done. We do this out of Maysville prior to shipping them. And again, we have whole kind of indexes that show you what cables to use, because we do have to convert. Our stuff is in minimum wire diameter, and Rockwell uses wire gauge. So we do convert all that for you to show you that, you know, you need a 16 gauge Rockwell, whatever the cable is, blank times your length, and ready to go. So we help with all that. This documentation's on our website. We in Maysville are assembling motors of what we call our size 4, 5, and 7. That's a 98, 115, and 145 frame. Our standard delivery is 3 to 5 days as an integrated gear motor. And for Rockwell, we only sell these as integrated gear motors. Now we are having a little bit of problem with some of the gearbox parts, so it is running out on some a little bit longer, but mostly we're still able to ship in 3 to 5 days a integrated gear motor. If I go to a larger motor or a smaller motor, I'm not building them in Maysville, and I've got supply chain issues much the same as every other manufacturer out there right now. We are willing to bring stock in on these larger motors to help with that for any customer. That's not an issue. Once we get started, we can have it there. And the EZ3 is being added to our production line in probably late March. The parts will be here, so April timeframe, and then we'll be in a 3 to 5 day delivery for the smaller motors as well. We also stock brakes in Maysville to put on the motors. Forced ventilation. This is a really, as we start talking about being more compact, this is another way of getting another 20 or 30% out of the motor, is to add a fan kit. And I know for like the VPL, you can't do that. The VPC and stuff comes with a fan, but this is something you can field add, or we can put it on. It takes a few minutes just to put the sheet metal around the connectors, tighten the standoffs, and you're done. Again, something we can add if the customers need more power, or if they need to do it in the beginning. It's not a problem. So we talk about adaptability, and here's where this modularity really allows us to do a lot of different things. You'll see us combining helical bevel units with Planetary and start to get huge ratios and very compact packages. It's all modular, it all bolts together. And if you start looking at these options, I mean, this is just integrated gear motor, just different physical options of right angle and inline and that type of thing that gives unlimited choices essentially in how we do it, all from one supplier. The compact size is a big deal. We get rid of, and this is whether you look at any gearbox right now, there is an adapter plate, there's an adapter and a shaft and a hub and a bearing, and in some cases a bushing, depends on the manufacturer. I throw all those parts away. I don't need them. My pinion of my gearbox goes right into the high-speed gear. So when I started looking at comparison of sizes, you start to see Rockwell MPLs are on the bottom there, and STOBER's on the top, and then there's other manufacturers in the middle just for relative size understanding. So you start to look at this and you start to see we are taking 20-25% away from the package. Again, not needed for every application, but there are those that really have a space constraint. So when we look at it, on average, we're 20% less. Sometimes it's as much as 40% of savings. And again, we're showing STOBER motors on these two units just to show the difference. But in either case, that same amount of change is prevalent across the product lines. So we look at another way of affecting that machine dynamics. You all have customers or yourself with right angle gearboxes on machines, and every time you add a right angle Planetary, you add more money. That's just the way it is. And we want to make the machine perform better and be less expensive. So what we're taking a look at here is we just grabbed the random customer that was using a VPL B1153. Winding really doesn't matter for size, but it does for the illustration of the speed and torque. And that's a very common motor. We see that a lot. And you know, we look at the length and we look at all the sizes of using a right angle with that motor. And we also looked at it with a slightly larger gearbox as well. So we did two different sizes just to show that it was consistent. When I take a right angle gearbox, my dimensions are fixed and how much I stick out. That's, you know, it's the same for all manufacturers, not the same dimension, but same type of problem. So my Planetary inline integrated geared motor is so compact that I can take and go into a system and only be 2 inches longer and have an inline solution that performs better and is probably $800 to $1,000 cheaper, or some number in there, just because I've changed that technology. And now I've got an inline solution that performs better. I got more stiffness. I got less ways to lose my backlash in that. And even in the next size up, I'm 3 inches longer. Now, many times that'll work in a system, whereas if you had inline with a Rockwell motor on here, it would have been 10, 12 inches longer by the time it would have got done with everything. Not quite, but in there. So again, this is all about changing the paradigm in that machine, making it less parts, making it tighter, and better performance. So we have lower backlash, we have much less inertia. I don't have to accelerate that whole right angle process, and I'm less cost. So we talk about the dynamics. I get rid of the clamp hub, I get rid of the shaft, I get rid of the coupling, I get rid of the bearing drag. I have my pinion is directly in the shaft of the motor. So I don't have to accelerate these items every time. So if I'm trying to get 120 of hits or something out of a system a minute, and the laws of physics are killing me. It happens all the time where you can't go any faster. The motor, you go bigger motor, it goes the wrong way. Smaller motor goes the wrong way. Sometimes I can make this work because I have a lot less inertia to accelerate and decelerate every time. So here I am, I'm able to help in that higher dynamic application. Now this is drive dependent, this is many application factors dependent, but in many cases we can find a solution that will work. And we looked at that same motor we were looking at earlier, we put with a 7-to-1 gearbox and did the comparison. I got 18% less inertia that I have to accelerate and decelerate every time. And if I'm trying to do 100 cycles a minute, that is a lot of power that I don't need now. And this allows this to come down. And in some cases, because I can have a higher speed gearbox, I may even be able to increase the speed of my motor, increase my ratio. That inertia even came down lower, and now all of a sudden I can hit it. So it's a whole balancing act, but we are apples to apples, much less inertia to accelerate every time. So I also have less mass, and this does not matter unless you're moving an axis. If it's on an X, Y, or Z or something, and it's moving, this matters. If it's stationary on a machine, you don't care. So again, but I have less mass, and that does matter if that's on a Z axis of a 3-axis system that's being excited and moved. Every little bit of mass reduction does help in the system. So I get rid of extra friction because I don't have a shaft seal in my adapter plate. Essentially, I have a motor shaft seal, which is lower diameter, which you would have anyway. So I have one less seal that's of larger diameter, and that's the one that generates lots of heat. So I need less power again. So this whole thing is one packaged unit. It's motors installed in the gearbox. It's been run already by us. It's able to be shipped out to your customer already programmed, ready to go. It's one part number, one vendor, one mechanical assembly. We've all been there on the side of the machine when you go to mount a motor to a gearbox and you drop the screw or the bolt and it falls and rolls directly under the worst spot of the machine. Maybe there's some oil there too on top of it. And it's just like working on your car. It falls between the fenders or something. Here we go. We don't have to worry about that. We got it already done for you. Many times in the days we all were chasing startup errors, and you would see an encoder error and you think, oh, I got a bad motor. And then you dig through it and you find you have a mechanical element that's not, tightened or something. And this happens a lot on gearboxes where people don't tighten the input coupling enough. And as you start to do a dynamic move, then you start to see slipping. So the key here is that this is a gear and this is locked. So we don't have any slipping. We're not going to be chasing a lost position error, thinking our encoder's not working, when indeed it's strictly been the coupling slipping. We're not going to have input bearing failures because we're not having motor installation issues on our gearbox. Frequently, we'll see customers, not frequently, but on occasion we see customers tighten that coupling up, then tighten the motor up. And what that does is puts a preload on the back of the motor and we start toasting bearings. Doesn't matter whose motor it is, all of us have the same problem. So again, we don't have that problem. We're not getting water ingress at that gearbox interface as well. And the other thing here is we cannot overpower the gearbox normally. We don't allow you to pick a larger motor than the gearbox can handle. Many times that's done in the field where someone put a larger motor on, and if they forget to turn the current down, they'll twist out the gearbox and that. So it doesn't happen. This is a particular application that we feel that we, in the end, would have been better solved with integrated motors for two reasons. This one in particular, assemblers did not tighten the couplings properly. They tightened the coupling, then brought the motors in. It allowed a bearing stress to come through the helical part of the gearbox and toasted the motors almost immediately. It was not Rockwell's fault at all. It was an assembly error. It was not, not Stober or Rockwell, so don't imply that. But if this had been our integrated units, this would have never happened. We also would have been more compact there, and this is a truck under a large AGV. It could have turned a little tighter possibly. So anyway, that's what we just show that as an example. So we also take these gear motors and we're doing more with food duty. So we make a lot of our helical bevel and some of our planetaries come in food grade units. So we may have stainless shafts, stainless fasteners and stuff. So now we're starting to combine them with a motor. Now we still have hard bridge points on that motor, so we can't be IP69K, but we are a microbial painted food duty paint and can perform under food or near food, not on top of food because of the fact that the paint could come off. So this is similar to what you're doing with the Rockwell food duty motors, but it's all nice system. There's no extra adapter in there. It's all O-ring sealed and stuff. So it's a nice package. Let us know if we can help you, or let Mac and Mac know. So this packaged unit is all about serviceability as well. We're a one-stop shop for spares. We can repair the stuff in Maysville. There is a way, I know this question will come up, is can I repair my unit in the field? And we do have customers that replace the input side of their gearboxes in the field. This is no different replacing a motor than it is an input. So as long as the oil doesn't drain out of the gearbox, so the orientation has to be such that it's either on a bench or pointing up, you can replace the motor in the field with 4 screws and a few minutes of time, as long as you're a careful mechanic that doesn't dump dirt and stuff in the system as well. So but we can do minor major type stuff in Maysville. Runs cooler. We've done some testing with our gearbox and a competitor's gearbox, and our flange planetary unit already runs about 7 degrees cooler than the planetary flange unit of the competitor. But now when we add our motor to it, we're another 7 degrees. So we're around 14 degrees less. Heat kills gearboxes. And if you're running these things to the point that the oil's nearly, boiling and stuff or disintegrating, we have less temperature rise and we can get more out of the gearbox and better life. So that's something, if that's the type of application you're doing, that would be a reason to look at this type of system. So we have hollow bore motors as well that work on the Rockwell system. And we can run electric wires through here. We can run another axis through here. We can run pneumatic lines or whatever. This is not a torque motor. This is a 3,000 RPM servo motor that drops on the 5,700 to 6,500. Its torque curve is just the same as a standard servo motor. It's got a hole in the middle. That's really what it is. Take this to another extreme, and we put a flange and a bearing on the front, and we drive the ball nut. So the screw stays, the screw traverses through the motor. So we can actually mount 5 or 6 motors on one screw, as long as you can do the programming that you don't smack them into each other. And the cool thing with this motor is this one here, you're seeing a brake on the back. Well, whenever you do a ball screw brake, you have to go machine the other end of the ball screw and make a bracket and put the brake on. Here it's all in the motor. We got the same, it's in the cables, just like you do a motor brake control. It's in your, you program it right in your RS Logics and away you go. Very easy integrated. So again, these are NDAT only and work with 5700 and 6500. This is one where we change again the dynamics of a machine design. Whenever you go to do a ball screw and you want to drive the ball screw, you have to put a couple of pillow blocks, or you have to buy an assembly that has this. A couple of pillow blocks, a motor mounting block that holds the front bearing, plus a coupling, plus then you have to secure the motor. You got a lot of parts involved. This motor here has a quill fitting in there of 20 or 25 millimeters, and it's a compression fitting. It is the end support for one end of the ball screw, and it is complete. So all you need here is one more pillow block, and you're done. Again, much more compact, much less pieces. This will, we can do this with DSL or NDAT, so we can do 5500 or 5700. Again, very compact, very nice setup, nice strong bearing there. And we're down to a pillow block and this, and we're done. So Stober sells a lot of rack and pinion products as well to complement both the motors and our gearboxes. We have a lot of options, and that's really what I'm talking to you here again about, is changing the paradigm of the machine in terms of options. We partner with Atlanta Drives on a lot of this stuff, so some of it may be familiar to you in the market. Again, we're talking about modularity here. We take these Planetary gearboxes, we take helical bevel gearboxes, and we start adding different pinions to them. We have shaft-mounted pinions that are of lower backlash quality, or higher backlash, I guess. These are more speed and more cost-effective, very easy to do. We don't weld the pinion on, so we put it on and it can be replaced. Then we start to get in ones that have different diameters, and we got much better torque for high force. So again, we're changing that diameter, and then we get into others that we'll have to show later, I guess, that offer higher speed. And so here's a typical example. We took a system that we've been comparing it with, and we simply changed the gearbox ratio and the pinion style and diameter. And if you go through this, you see it's the same performance out of both, and you see we're slightly less cost, but we're also much less linear backlash, much less torsional deflection, much less linear deflection, and more linear stiffness. Again, because we've changed the ratio, we've changed where those inaccuracies are, and we've increased or changed the diameter of the pinion. And that's how we made that happen, and we did it for less cost. Again, it's all about the options and the modularity allowing us to do this, and we'd love to help you with this type of project. This is one that's really a machine tool almost. This is a large support bearing for the outboard side of a pinion. And if you're using a large gantry system, a lot of times we can go one gearbox size smaller because of this. This is a more of a specialty type thing in the rack and pinion world. And this is one where we can get some high speed in there. So we offer, tinier diameter and larger diameters. These are bolt-ons. These are indexed in there. You can change them if the pinion goes bad. So again, a lot of flexibility. Our racks, one of the cool things is we can do a 2-meter rack, which in one piece, so you don't have to worry about joining it. And a lot of times that'll do a lot of applications. But again, just like everyone else, we can join them for unlimited length of travel as long as your system will go. So again, flexibility. So this is a product that we've been working with Rockwell on. This is a dynamic safety brake. This will work with the Rockwell safety motors, the 24 motors that have the safety encoder on them. This one will meet some of the levels of PLD, and that is a system safety component with the guard logics and guard master controllers. The unique thing with this is Rockwell now has a 62-page bulletin which details how to use the safety brake function and this unit. There's the link. You can search safe brake control application in Rockwell and download this. And what you'll see is some really cool things here. We integrate this brake right into our gearboxes. Again, the pinion of the brake goes right into our gearbox. We don't have a connecting pinion. We have a lot less room for air. Your safety motor goes on the back. That gives you redundant channel. And we're on the back side of the gearbox. Now we have to sell this with our gearbox. So now we take the 400 Newton meter brake and you multiply it by the ratio and you start to have a very substantial brake. And it, fits our gearboxes. These are stocked in Maysville to be added to our gearboxes for the Rockwell motors. All the motor plates are in stock. So this is a spring actuated brake that uses 24 volts. We can do a 230, but that's not stock. That's a fast rectifier. And the cool thing is you can even take the motor off of this when the brake is on, and your load can't fall. So if you have a vertical load, this is an awesome thing for safety in the plant, and that it's not rocket science, but it is, it's a magnetic coil. There's brake discs that you can actually hone or regrind through a process. There's a window that you can stick your feeler gauge in to measure the brakes. We even offer for some of them sometimes a safety hand release, which you would not probably use on a vertical application, but it is an option that's available as well. So again, these are on vertical axis. These will stop the load within most of them are designed around 40 milliseconds. You can take your motor off, and it's just a good package. Now, we get a lot of requests for these with belt slides. And if you do your safety analysis on your machine, you'll see that your belt slide, if your belt breaks, all bets are off. I don't care how good everything else is behind it. So not real keen on doing belt slides with these. But if you have a solid mechanical element, like a rack and pinion or something on that vertical, this is an awesome way of working around it. So what separates Stober from the rest of the competitors you can choose from? We have such a wide range of everything from Planetary to helical bevel to geared motors. And we can match any servo motor, but we have the ability to do it with our own internal motor as well. We have 24/7 service. You can call us. In a lot of cases, we can ship something within an hour on a weekend. We do it several times a weekend, every day. It's really limited by the courier service or the plane ticket net in terms of how fast we can get it to you. We ship some of that stuff out in an hour without paint even on it, because the paint would take that much longer to dry. In that case, it's just strictly emergency to get it up and running. Everything we use is the best we can buy, the best seals, best coatings, best lubricants. We offer you support both to your distributor and you as a customer for the application and help with that. And our deliveries, our gearboxes normally are build and ship in one day. We're a little bit of issues right now, but for the most part, we're hanging in there. Geared motors were 3 to 5 days. We can rush it some, but that just is a standard. So delivery wise, we build to order. We have about $9 million in parts sitting in Maysville, Kentucky that allow us to build at a moment's notice. And many of these things are modular, and that's where it allows us to have that flexibility. So when you go for support, our gearboxes are on Motion Analyzer, the cloud. I know the new version's getting rolled out. We're on the cloud. We'll be on the other version as well when that's released to you guys. The synchronous servo motors are going to be worked on the first of the year after they get done with the release of the desktop version. But some of our hollow bore motors are on there as well, if that helps. But we're willing to take your Motion Analyzer project in our facility, and we will size it on a gear motor for you, and then send it back to you. So we're okay with taking the Motion Analyzer cloud and trying to help you with that. So don't we want the data, and that's sometimes the best way of getting it. So where do you go for support? We have global support. We support both you and the distributor working together as a team. We have aftermarket. We have emergency service. We have a full website with catalogs, brochures, application ideas, videos, just like everyone else. We have a real nice configurator online now, and you can always contact Mac and Mac at any point. You can also contact Stober and let us know you're working with Mac and Mac, so we make sure we tie that together real quick. But we have third-party, 3D product configurators on our website, which is the quickest way to build what you're looking for. STOBER has so many options, and it's very hard in print to describe those. And the pictorial representation through that configurator is awesome. You can go right there and get a drawing, or you can start to see how these hollow bores and all these right angles would fit in your system. Again, we have YouTube channels as well, and I appreciate sincerely your time today. Hope it was worth it. Again, we're a bronze technology partner with Rockwell. The one thing that I probably should explain a little more is when you pick a geared motor, you simply go to the list and let off on the mouse, just as you would you search EZ blank as you would VPL. So it's the same as integrating that into your system. So it's very easy to do. Further questions, Mac and Mac, their email address, mcmclive@mc-mc.com is shown there, and stober.com will get you the rest. Again, appreciate it and hope you have a wonderful day.
Thank you, Dave, so much. We'd like to allow just a few moments here to see if anyone has any live questions here for us. I don't see any in the chat right now, but that doesn't mean that people don't have them. I also have some questions that our customers might have for you. If you'd like, we can go over those and see if we get any follow-up questions from the audience.
Wonderful.
So one of those questions might be, if an integrated geared motor fails, are my only options to return it to the factory for repair?
Well, that's one option. The other option would be we ship you the motor with the pinion already mounted on it, and the machine, you remove the gearbox from the machine, tilt it up so the motor shaft is pointing down, remove that 4 screws, pull that motor off, clean the gasket, put a new gasket on, which we send you, and stick that new motor on. So that is possible. That's done just the same as our motor, adapter motor mountings are done. Our front ends, there's YouTube videos that show that. Like I said, beyond a socket wrench and a torque wrench and a rag to clean up the mess, it's not a hard process. It's if you're a careful mechanic and don't make a mess, you're good to go.
Wonderful. That makes it a lot easier on our customers and a lot of different options there. That's really wonderful.
Right.
And with the servo stop safety brake, does the Rockwell automation publication show me how to size this?
No, there's a lot of factors that go into the servo stop, and we're looking at inertias of the loads, and we're looking at stored energy, and the 60-something page book by Rockwell really goes into the integration of this product into the GuardLogic and GuardMaster controller. It sets up the wiring diagrams, and it sets up the ways of programming that and integrating that into your system. So that is something that STOBER takes on when you want to use one of these. We work with the distributor and the end customer, get the data, go back and forth, and size it appropriately so that there's no question, because it is really a safety component. We want to make sure we're part of that.
Absolutely, yeah. And last question that we might get is, can STOBER do an integrated geared motor for the K5100 and 5300 series drives?
Unfortunately, we've chosen to do the DSL for the 5500 and 5700, and not the feedback options that are offered on the 51 and 5300. That's a different encoder that won't fit in our motor. So for now, we're 5500 and 5700 and 6500 compatible.
Wonderful. As Dave mentioned earlier, you can always reach out to us directly at that email address there on the screen if you have any follow-up questions, or if you're watching this as a recording and you have a question for us, just let us know the title of the session that you attended, and we'll direct your question to the right person and get someone in touch with you. I want to thank you, Dave, for this wonderful presentation. Thank you to John as well. Thank you to Randy for being our resource out in the comments section. And thank you especially to all of our live viewers for your time here today. We hope this session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel and join us again next week for more industry content like this. Thank you, everyone. Have a
Thanks,
wonderful
Rachel.
day.